class. Good morning. So let us now take up this topic in engineering economy. So this is break-even analysis. Okay. So what is a break-even analysis? Okay. So break-even analysis is used to determine the break-even cost, which is the cost at which the total income is exactly equal to the total expenses incurred in the business. Okay. So take note, class. If the total income is exactly equal to the total expenses, that is called the business is at break even. Okay, so break even. Okay, so let us now consider the diagram here. Okay, so the line uh, perpendicular or upward, so perpendicular to the horizontal line is called the revenue, and the horizontal line or the abscissa is called the production. Okay, so the line coming from the intersection of the revenue and production up to this point is the so-called uh, the income. Okay, the income, and the line, of course, from the horizontal line above the production is called the total expenses. Okay, so the income is this from the origin, and then this line from the fixed cost line is the total expenses. So take note, class, that the intersection of these two lines is called the break-even point. So by this time, the break-even point now is the time when the total income is the same as with the total expenses. You look at this, class, okay? So equal. Okay. So behind, of course, the break-even point is loss, and the area, of course, above the break-even point, of course, is the profit. Okay. So you will notice that if the uh, two lines intersect, of course, here, so above here is the income. So take note, class, that this is the variable cost. Okay, variable cost. So that is the area, of course, beyond the area covered by the loss area. Okay. So actually, class, there is no such fixed equation in computing the break-even point analysis. Okay. So this is somewhat like solving an algebra problem. Okay. Okay. So in order for us to be uh, familiar on how you are going to solve problems in this analysis, so let us consider an example, class. Okay. Okay. So this is MA Board, August 1969. An item which can be sold for 63 pesos per unit wholesale is being produced with the following cost data. Okay. So 10 pesos per unit, material cost 15 pesos, fixed charges is 10,000 pesos, variable cost is 8 pesos per unit. Now, the problem is, what is the break-even point sales volume? Okay. So, here you are going to determine the amount, the number of unit that you are going to uh, consume, or of course purchased by the customer, of course. Another is, what is the break-even point sales volume if 1 unit of every 10 units produced is defective? Okay, so there is a defective unit during the production. Okay, and is rejected with only full recovery of materials. Okay, so let us now, class, solve this problem. Okay, so for letter A, So let us consider X is equals to the sales volume. So considering there is no such reject, of course, of the unit produced. Okay. So that is 63. So that is the the price, of course, per unit. 63 multiplied by the number of units. So by this time we are going to determine the number of units, so which is X. So that's why we have here 63X is equals to the cost. Okay, 10,000, which is the fixed charges. Okay, another is 10 multiplied by the number of unit, which is the what? So that is material cost. Okay, another is times or minus 15x. What is 15? So that is the, okay, and then fixed cost rather, and then 8x. Okay, so what is that? 8. So that is the variable cost. Okay, variable cost per unit. So getting now the value of X, so that is class 33 or 333.33 units. So if you sold uh, a number which is 333 or 334, that is now at break even. So in excess of this, so 334, 335, so there is now a profit, of course, derived, of course, from the business. Okay, so that is class. Okay, so another, that there is a defective 10%. Okay, so here, so that is 90. So because 10% is defective, 9.9x is equals to the number of units each month. Okay, so we have here 0.1, x is equal to the number of defective units. So again, equating now, that is 63 multiplied by 0.9. So is equals to 10,000, the same cost. 10x minus 15x plus 8x minus, okay, so this can be subtracted. So this is the defective materials or product. 0.1 multiplied by 15. Okay, so the value now is 396. So meaning class, if you sold 396.8 units, you are now at the break-even point. Okay, so if you sold 400 up, there is now an increase of profit. Okay, so that is class how you are going to solve the break-even points. Okay, another we have here in aboard March 1970. So in the manufacture of certain product, two processes are available. One will produce 80 units of the finished product per 100 worth of raw materials and will cost 42 centavos or 0.42 pesos per unit of the finished product. The other will produce 87 units of the finished product and 100 worth of raw materials will cost 0.56 per unit, okay, of the finished product. What is the break-even point if in unit value of the finished product below which the low efficiency process should be used and above which high efficiency should be used? Okay, uh, quite difficult class. Okay, so can you imagine? Okay, so let us now take the solution. So again, for the first process, so x is equal to number of unit value, okay, of selling price of the finished product. Okay, so expenses is equals to 100 plus 0.42 multiplied by 8 equals to 133.6. Sales equals to 80x. Profit equals to sales, of course, minus expenses. So the profit is 80x minus 133.6. Okay, so for the second process, again, so expenses 100 plus 0.56 times 80, 148.72. Sales 87x. profit equals the same equation. Okay. So in order now to break even, let us now equate these two equations. Okay. So in the above process, so that is 80x minus 133.6 is equals to 87x minus 148.72. Okay, so therefore now x is equals to 2.16 pesos. Okay, that is the unit value. Okay, so it is quite difficult class. Okay, so but if you know, of course, what are those things that you are going to consider, the solution is quite easy. Okay, thank you very much, class. So that's all about my presentation in engineering economy. So wait, class, for another presentation here in order for you to be equipped with more examples. Okay, and it is easy for you to understand how you are going to solve problems in break even points. Okay, or the break even analysis. Okay, thank you very much, class.